We have more examples for the use cases of the for loops, such as nesting for loops inside one another. So in this case, if you want to output a rectangular shape using the sharp symbols, we can do this by writing two for loops inside one another. So the first for loop keeps track of the height or the rows of the rectangle, and the second for loop inside this one can keep track of the columns in each row. In that way you can simply print a single sharp symbol inside this nested for loop without any termination new line, and then simply print the new line at the end of this row. So the first sharp is output, second one without the new line, and the third one. At the end of this third one, we simply insert the new line using a blank print statement and go to the next line and repeat the process. So the for loop, the inner for loop itself is repeated by the outer for loop for this purpose. So you have the example here. But actually, before actually telling you the actual part, the naming of the loop variables is very important. So if you are used to writing for loops like this, for underscore in some range, let's say 7, and inside this one for, if you use the same variable name, there's going to be a mixture of assignments. So this variable is going to be assigned all these values, and then it's going to be assigned these values as well. So if you need to print something or make some function call depending on the value of the outer loop variable, and if you reuse that name inside the inner loop, you will end up with different values. So you should be careful about the naming of those loop variables. The best practice is not to use the same variable name for inner or nested for loops. It's one of the most common mistakes when we are writing the nested loops. For instance, we generally provide the loop variables as I, and inside that one we use the j, and if you still have to go further inside or nest more loops inside the other ones, you can simply use I, j, k, l, etc. So in order, if you make this a habit or a good practice, it's going to be preventing so many mistakes before they happen. So memorizing this for loop as for underscore in range is actually sort of a dangerous habit. So if you start writing them all for underscore in range something, and the inner loop is going to be written automatically by your hand. So make use of using meaningful names, okay, or whatever this loop variable is keeping track of. It might be a range assignment, or it might be some items in a list. For instance, student names or student numbers may be iterated instead of this range function. So if we had this course names like this, CMP 150, Math 101, okay, instead of the range function. So we have these course names. We can use our loop variable as the course name, and from there we can use another loop variable to be the hours of that course. So the course hour that we can retrieve from a dictionary or somewhere else, okay, that we can get, for instance, hours map of the course name. So I would initially have something like this. Course hours is going to be a dictionary such as CMP 150. I should type it as a string. CMP 150 has the hours, let's say Tuesday 7 and 8, okay, and the Math 101 would have the hours, let's say Monday 3 or Monday, Tuesday, Friday as 2, 5, and 7. Okay, so this is my dictionary of course hours. So now I can, sorry, I need to make them as the same. This, I need to write them the same. Now I can print the course hour on my terminal. Okay, so this is a dictionary for me corresponding to 150. I have Tuesday 7 and 8, and Maths has other hours. So for each course name in my list of courses, I obtain the course hour from the course hours. And if I run this, well, it returns the entire string. So this assigns, it retrieves this string. So the in operator actually traverses over all those string items as characters, and it displays them one by one. Okay, so it has Tuesday 7 and 8, which might be our intention in this case. So we want to first check the day of the week and the hour, and then we have 3 days for maths and 3 hours. So this is one way of interpreting this nested loop, but the loop variables need to be different from each other. If you have something like this, print course name here, and if you mistakenly, so let's run this in this way first. It displays Math 101 and CMP 150, but if I have accidentally used the course name variable in both loops, the result is not going to be the same. It's not going to display this course name initially assigned to 150 or Math 101. Instead, it's going to output the last value retrieved from this course hours item, which is going to be 8 and 7. So we have 2 8s and 2 7s displayed because the final value placed into this course name is coming from this list of characters, and what I actually wanted to do was to display CMP 150 at the end of this list, okay, at the end of printing this sequence of items, but using the same variable name in nested loops, simply simply prevents that because it overwrites the value. So I should not be using the same naming, course, hour, and also use the same here. So now I am using separate variables in two for loops, and they are not going to be colliding with each other. And I can have my course name after the course hours displayed. Okay, now we had this square drawing function with nested for loops, but actually Python is strong enough to handle this case with single for loop. You would remember that we can multiply a string with a number to replicate the string as many times as the number. So when you replicate this sharp symbol with the width of the rectangle, then you can handle this case only by tracking the rows of the rectangle. So I will just simply multiply this sharp symbol with 3 and print the entire row within a single statement, and repeating this process 5 times gives me the same rectangle. Okay, there is this dashed line example. These are exercises for using for loop with the dashed. You would remember the dashed line or dashed shape, dashed circle or dashed polygon. We can shift our rectangles to the right using some spaces before printing each line of our rectangle. It's simply done by adding an additional for loop before the for loop that prints the row, a single row. So if you insert spaces as many as the offset of the rectangle, which is the spaces required before the rectangle itself, we would be simply shifting the sharp symbols to right. Okay, you can also convert this to a single for loop case. Think about it. We were multiplying the sharp symbol with some number. You can also multiply the space symbol with some number and concatenate those values together to obtain the single row, which starts some spaces followed by another number of sharp symbols. Okay, now we have this triangle example where you're going to display a single star or symbol asterix. Now inside the outer for loop, which keeps track of the rows, which keeps track of each line, we have this inner for loop which repeats printing process as many times as the height we are currently in. So we are in the first line initially. So yeah, we are in the first line. So it has the value 0 actually. That's too much. It has the value 0. So we have this range height. Height is 10. So we start with 0 and continue with 1, 2, etc. up to 9. So in this case, our row or our column tracker is going to start from 0 and go to height plus 1. Height value is or h value, sorry, h value is 0 initially, so we are iterating over this list for the height, and we are going to iterate over 0, only 0 for h plus 1, because h is 0, 0 plus 1 is 1, and range 1 is 0 only, it doesn't include 1. So this loop is going to be executed only once, which is going to output this single star. And if we are going to output the second row, it's going to be displayed for the value 1. Range 1 plus 1 is 2, so it's going to give us the values 0 and 1. This means that this inner for loop or nested for loop is going to be executed twice. So it's going to output 1 star for 0 and another star for 1, which is the case in the second row. Okay. You can also try converting this with a single loop without this inner part. Just multiply the star with the value you obtained from the range function, and you're going to have the same result. So I think this is the offset. Okay, this is the offset rectangle. This is the triangle that you're going to see. In order to convert this to a single for loop, you can simply print star times I think h plus 1 is going to do it, because it starts with 0, and you can simply ignore this part, sorry. Simply ignore this part, and also you can get rid of the print statement. So this is going to have the same effect. Okay. It was just for demonstration of nested for loops, but Python is clever enough to replicate strings by multiplying them with numbers. And this is the isosceles triangle. So in order to output this triangle, you have to first include some spaces before each line. I don't know why it keeps doing this. So before you print this star, you have to add this many spaces before that lines, and one less number of spaces at the second line, and two less number of spaces at the third line, etc. So before you start printing this sequence of stars, you have to calculate how many spaces are required at the beginning of each line. And this code does exactly that for you. So you make a calculation. You have the height value, you have the current row value. So it starts with 0, goes over to 9, excluding 10. Okay, 0, 1, 2, etc. to 9, and then it prints these spaces as many times as required in each row. It is decreasing the number of spaces is decreasing as x is increasing. So height is constant. If this increases, the difference simply decreases, and the spaces printed before each line goes down to all the way down to 0 for the last row. And for each line, it prints simply the current row times 2 plus 1. So it goes 1, 3, 5, 7, 9, and so on. Let's run this code as well. You can also convert this to a single line code instead of writing this many for loops. I think it's going to be something like this. Print spaces times how many spaces are there, height minus h, but I have to use this parentheses. I think I need to add one to the result. We will see that. And let me delete this part. And we're also going to append the stars multiplied with again using a pair of parentheses. And so I should take this part, place it into here and delete the remaining part. If I am lucky, it's going to output this, but there's some spaces before, so we need to fix them. I think I have too many of them. I can simply delete this one and rerun my code. Do I have any? Yes, I have another space, so I should be subtracting one from this space drawing part of my print function, and I don't have any spaces before the last line, so this is a single line solution of this code. So there is never a single way of solving a problem, especially when it comes to Python programming language. You can also offset the same triangle, adding some spaces. So it can be written like this. I have an offset value as a parameter. So I'm going to add this offset value to the already present space insertion calculation, and it's simply going to add the offset to the number of spaces. And if I run this like this, now I need to provide the offset as 20, let's say, and run this code. Now it has shifted my triangle to the right, so there are 20 spaces inserted before the last line, but my program starts drawing from the topmost row. Okay, there's no such thing as printing the last row and going above it. Okay, the program goes from this first line, prints the second line and the third line, etc. So you should be careful about that. Make your calculations accordingly. You should find the largest row and define the necessary amount of spaces according to this one, if you need to. In this case, we just make the calculation and we know that how many spaces are necessary for each row, because we know the height of the entire height of our triangle, and we can calculate the necessary spaces for each line. Okay, you can now draw a tree using our triangle and rectangle drawing functions. So the number of spaces required before this rectangle is dependent on the entire width of the triangle, so we can center our trunk according to this triangle. Okay, according to the leaves or branches of our triangle, our tree. So you need to make this calculation first, and you have the offset, which is common. So the offset is this, according to the largest part of the tree itself. And from there we also have an extra spacing for the trunk, which is calculated according to the width of our tree and the width of our trunk. Okay. And this example simply does that for you. So it first makes draws a isosceles triangle with some offset and calculates the offset of the rectangle to be the difference of this part of the tree itself, the triangle part of the tree, and the width of the trunk. So if we run this example with different values, so I have these values now. If I want to change the height of my triangle to be 7 and the width of the trunk to be 5, I'm going to end up with a different tree. Okay, but the trunk is going to be centering. It's going to be aligned to the center of the tree according to these calculations. You should all go over these calculations so that you understand the mathematical expression. If you need to draw some shapes, which I believe you all will in your exams or other assignments, you should be familiar with this kind of calculations. You can also draw these shapes. So you can define other functions that can output trees or triangles, multiple triangles on top of each other. So if you need to center them, in this case you do. So you have a triangle of height 3 and a triangle of height 4 placed on top of each other. So you have to center them, align them according to this largest part of the tree. And then you're going to add some, so this is the offset of your tree. Okay, you need some different amounts of spaces according to this part, according to the largest part of the tree. And the trunk is already aligned. You have the code for it.